Hello everyone, I am the rookie computer engineer and this is the beginning of a course that I will be teaching throughout the next several months probably, as this will probably take up a lot of time to talk about digital design. A little bit about me before we begin. My name's Henry. I go to Penn State. I'm a computer engineering major myself. Those three pictures on the right are just pictures of me, of course. My specialty is digital design and hardware description. It's my favorite part about engineering. I really hope to work with FPGAs, which is how we're going to actually be implementing our designs. I work two jobs. I'm a hotel housekeeper and also an IT support technician as while I'm in college. It's pretty rough, but I've got to do what I got to do to get through this. I am the treasurer of our Model United Nations Club, something that I'm really proud of. We basically, if you don't know what Model UN is, that's a whole nother topic, but it's basically speech and debate, but talking about politics, and those politics being about international affairs. Some of my hobbies are video games. I love video games, which you'll probably be seeing videos here and there come out about the video games that I like or the video games I don't like. I'm an avid soccer fan. My favorite team is Manchester United. They're the best team in my opinion, even though we've had rough seasons for the past five years at this point. And that's pretty much it. Moving on. So basically how this course is going to work is I own a Basis 3 FPGA circuit board, which that is what you're seeing in the top right there. That's what we'll be using to actually, that's what we'll be programming. We'll also be using Vivado. I have version 2017.3. Of course, Notepad++ before you actually put in Vivado, because Vivado tends to be very demanding of a machine. So if you have a machine that's maybe on the lower end and you want to follow along, I just recommend using Notepad++ instead of actually using Vivado. You can download Vivado versions of Vivado. I got mine for free. There's no license required to actually use it. However, there is limitations if you don't have the full version of Vivado. It's not compatible with every single board. It doesn't have as many features as the full version. But for what we'll be doing, it's perfectly fine. It's perfectly valid. Everything that we do, from basic computational logic to coming up with our own systems and different ways to implement those systems, it can do all of that. As long as you know VHDL, you can do anything. We also are going to be using PMODs as we get further into the course and as we start making our own projects. Like for right now, I actually have a hexadecimal pin pad that I used in my final project at Penn State, and I also used a infrared motion sensor. We actually we made a motion detected home security system, which was very basic, but it was a lot of fun, and it was very exciting to actually see it work. So I definitely recommend getting Vivado to download. If you don't have a Basis 3 board, that's fine. I don't recommend going out and buying one of these. If you're in college right now, you will probably end up buying one of these or another kind of board similar to it if you have a similar digital design course. But the Basis 3 is the best board for students. It's what I've used for the past couple of years, and I hope to kind of just play around with it in the future. The actual language we'll be using is VHDL, as I mentioned earlier. VHDL is a hardware descriptive language. It's different from a programming language. A programming language is how you make software applications, um, and so on and so forth. But hardware description is specifically describing exactly how a system such as the Basis 3 board or an FPGA is actually made, and actually, well, not made. It's how it's designed to work. Um, FPGA is very common in simple systems. Simple systems will definitely have a dedicated processor to work a certain way and perform certain tasks. And we use hardware descriptive languages to actually perform those tasks to begin with. What we're going to cover, the first section is going to be about combinational logic. It's a very simple introductory course. Actually, sections 1, 2, and 3 will actually be very, very short, maybe a few videos. So in section 1, we're going to be talking about basic logic, what a truth table is, what binary is, what hexadecimal is, all of the basic stuff before we actually start getting into legitimate projects and legitimate designs that we'll actually be implementing in the future. So if you're a beginner, like dead beginner, I recommend just watching all of section 1. If you obviously know what a truth table is and you know how logic works, you know what AND or XOR means, then I would just move on past that. VHDL and Vivado, that's how we actually start getting into how VHDL works, what is the syntax behind it, how Vivado works, what we actually need to know about Vivado, how to use a simulation, how to use a test bench, the differences between synthesizing, implementing, and generating a bit stream, being able to bring up an elaborated design, so on and so forth. Section 3, combinational projects. This is where we start getting into legitimate projects. It won't just be this bullshit PowerPoint shit that I got going on right now. It's the best way I can come up with to explain things because I don't really have the best video editing skills, so I just figured, why not just slides? So in section 3, we'll get to legitimate projects that we'll be working on. They won't be too advanced. Combinational logic can only get you so far in most designs, but it's really cool to see how it works on the actual FPGA board and how data will flow through a system. It's pretty great. Section 4 will go over sequential design, so that's actually instituting a clock into your designs, being able to time properly what timing is in the first place, making processes, which is how you get into your higher level programming. Since hardware description is kind of a low level, but the actual hardware descriptive language is high level, there's a lot of designs that you could potentially do with that. There's a lot of processes that you can come up with to perform multiple tasks at once, finite state machines, being able to do the difference between a data and the clock being sent from different devices. It's pretty interesting. When we get into advanced digital design, that's when we'll be talking about PS2s. PS2s is, if you don't know what these are, that was before USB. That's how you actually use keyboards and mice. Was using a PS2 port. Luckily, the Basis 2 or the Basis 3, excuse me, uses a USB port, but that USB port can actually work as a PS2 port as well. So it can encode and decode whatever input it's getting from a USB and use it as PS2 data. We'll also talk about VGA, how we actually can set up a VGA screen, how to actually put images to life. That's a lot of fun. Um, Section 6 is going to be timing and performance. So after we get past all of the designs that we want to do, whether it's combinational based or sequential based or getting into VGA, PS2 sort of stuff, that's when we want to get into the actual timing and performance of the device. Any design that you make, you have to take into consideration how much time it takes for these tasks to perform certain ways. I actually ran into this problem when I was doing my final project for college, and that was we couldn't get the timing of our pulse generators to work correctly with how data was being sent through the board itself, so it caused a lot of problems, is what I'm trying to say. So timing and performance is pretty essential to digital design itself, and being able to understand that, you can get even more complex designs and being able to make them efficient. Section 7 is I just called it algorithms because algorithms are algorithms. If you've ever taken a class about algorithms or discrete mathematics, this is where it actually starts to take into effect. We'll be hopefully making designs that use algorithms that we can literally program into the FPGA chip on the Basis 3 board to be able to perform lots of tasks in a very short amount of time. So that's how generally processors get developed, is that once you go through a design, it gets tested 100,000 times, so to speak, and then you use the algorithms that you designed in the first place and keep on improving them. And the last part, we'll be doing projects like a lot. Projects is just going to be part of the course. I'll be placing the projects that I think are helpful to whichever respective section that it applies to. So if it's a really basic project, it doesn't even use a clock, I'll put it in the section 3 playlist. If it does something more complex, maybe uses the PS2 keyboard or uses a VGA screen, maybe I'll put it in the advanced digital design. Let's say I make a new algorithm that works and I wanted to share it, then I'll just, of course, put in section 7 respectively. So what actually is digital design? Digital design is the application of logic to be used in microprocessors. Basically, any logic that you can come up with a combination of AND or XOR gates, can all be used in a microprocessor to perform certain tasks. What we're doing with digital design is we're literally describing what is happening in the processor. So on an extremely low level, we're taking the circuits that are comprised of, mainly transistors, let's be honest here, to perform certain tasks, to come up with data that will, and you can use that data to make actual performance occur, if so to speak, if you're catching what I'm saying. You can use digital design to combine just combinational logic and sequential logic to create any process to perform simple 1+1 operations to home security systems, making a game of Pong if you wanted to. And basically the bottom point here is that digital design is a fundamental subject for computer and software engineering. You are not going to go anywhere if you don't understand how digital design works, how to make a project, how to implement that project, how to verify that project, and then keep on improving it as you go and go and go. Because with digital design, you start with something small, you make it bigger and bigger and bigger, and you think you're done with the project, but you know that you can always make it do more. When we were going through our final projects at Penn State, holy guacamole, did everyone have a bunch of ideas about what they want to do after they're done with the final project that they present and that they do and that they demonstrate in front of the class. And that's the thing about digital design, is that you can start from nothing and get anywhere. But the point is that you can actually do anything with digital design using FPGA. You're not limited to just one AND gate or just two AND gates or three AND gates. You're basically limited to what the actual physical capacity of the board is, or whatever chip that you'll be using in the FPGA. So there isn't really an excuse as to saying, oh, I don't think I could do that. It's like, actually you can. It takes a lot of time, it takes a lot of patience, mainly patience really, to do it, but you can do it. It seems complex at first, but it actually gets easier as you go. With that being said, in the next video, we'll be beginning section 1, combinational logic. We'll be talking about what logic gates are. We'll be doing I'll be demonstrating what those gates mean for Boolean algebra, the operations that these gates perform. Later we'll talk about the different numbering systems that are common in processors and just in engineering, in software, in computer engineering. Obviously the main ones you're going to want to know is binary and hexadecimal, but octal is put in there for some necessary concepts. We'll be talking about propositional equivalence, which is used a lot in discrete math but is relevant to digital design as well, and what tautologies and contradictions are. That's going to be basically just one point. What is a tautology? What is a contradiction? So on and so forth. So if you liked the video, go ahead and give it a like. If you are interested in actually learning digital design, please subscribe. I'll try to make these as much as possible, but you gotta forgive me. Sometimes college does bog me down, but I'm really interested in this stuff, and I really hope to share it with you guys. So I hope you stick around, and maybe we can learn together. I hope you guys have a good rest of your day. I'm the Rookie Computer Engineer, and I'll see you in the next video.